Hello and welcome to the session on time, speed and distance. This is brought to you by Handa Ka Funda. Let us talk about a few other cases. Say a river flows from the point P with the speed of SR. A boat can swim in still water with the speed of SB. Then what will be the downstream speed? Downstream speed will be speed of the boat in still water plus speed of the river. Why so? Suppose the speed of boat is 8 meters per second and speed of river is 2 meters per second. Boat on its own can go for 8 meters in 1 second. The water flow will push it for 2 extra meters in 1 second. So total distance it will gain is 8 meters plus 2 meters or 10 meters. That is why when going downstream it will be speed of boat plus speed of the river. The upstream speed will be given by speed of the boat minus the speed of the river for the same reason. The boat on its own can go for 8 meters. It will come back by 2 meters because of the river flow, and the actual distance it will gain is going to be 8 minus 2 or 6 meters. So if I am given the speed of the boat in still water and the speed of the river, I can find out the downstream and upstream speeds. What if I am given the downstream and upstream speed? Can I find out the speed of the boat and the speed of the river? Yes, I can. Speed of the boat will be given by downstream speed plus the upstream speed by 2, and the speed of the river will be given by downstream speed minus the upstream speed by 2. The point to note is the downstream speed will always be more than the upstream speed. Another thing that you need to notice that the speed of the boat downstream, speed of the boat in still water and speed of the boat upstream, they are always in an arithmetic progression. Why so? Suppose speed of the boat is 8 meters per second and speed of the river is 2. What does that mean? Upstream speed will be 8 minus 2 or 6 and the downstream speed will be 8 plus 2 or 10. As you can see, they are in an AP. They are in an AP with the upstream speed being the smallest value, downstream speed being the biggest value, and the common difference being speed of the river will act as the common difference. This tells us one more thing, that if these speeds are in an AP, the distance from P to Q is constant. And suppose you are going from P to Q, once time it's downstream, once it's upstream, then the times taken, they are going to be in a harmonic progression. That is, the time taken downstream, the time taken by the boat in still water, and the time taken upstream, they are going to be in a harmonic progression because speed is distance upon time, and if my distance is constant, speed is inversely proportional to time. So if these are in an AP, their reciprocals, which will be representing by time, will be inverses or they will be in an harmonic progression. Please remember, you can use the downstream upstream funde for escalator questions as well. Suppose an escalator on its own can move at the speed of 5 steps per second. You can run on it with a speed of 10 steps per second. You have to go from the bottom to top, and that is 30 steps. How much time will you take? Escalator on its own will climb at 5 stairs per second. You will run on it at a speed of 10 stairs per second. So total in 1 second you are gaining 15 steps. The total distance is 30. So that will mean you will take 2 seconds. What happens when the escalator is going down? When the escalator is going down, you are also going down. So that means the down speed will also be 5 plus 10. That is essentially the biggest difference in a downstream and an upstream case and an escalator question. In downstream and an upstream case, you are swimming once with the flow of the river and once against the flow of the river. However, when you are going on an escalator, you are going with the escalator when you are going up and you are going with the escalator when you are going down. Let us look at some of the cases in a linear race. Let us talk about a race of 100 meters. There are two people, A and B, who are running. Speed of A is 20 meters per second and B is 25 meters per second. Which tells me that the time taken by A to finish the race will be 5 seconds and the time taken by B to finish the race will be 4 seconds. Since B is the faster guy, he is winning the race. He is completing the race in a smaller time. The win can be said that B beats A by a difference of 1 second. If you want it in distance terms, it could be their speeds are in the ratio of 5:4 So the distances that they will cover will also be in the ratio of 5:4. B is the faster guy. When he finishes the race, he has covered 100 meters. A, in the same amount of time, that is in 4 seconds, he would have covered 4 into 20 or 80 meters. So we can also say that A beats B by a distance of 20 meters. Since B is the faster guy, he decides to give A an advantage. He decides to give A an advantage of 20 meters, which is also referred to as a start of 20 meters, which means A will start from a point P dash, which is 20 meters ahead of B, which means that A has now to cover only P dash Q, which is 80 meters, whereas B has to cover the entire distance, 100 meters. So think about it, how much time will they take? A has to cover 80 meters at 20 meters per second, he will take 4 seconds. B has to cover the entire distance of 100 meters at 25 meters per second, or he will also take 4 seconds. As you can see, both of them are taking the same amount of time, which means that the race will finish in a dead heat, or both of them will reach at the same time. If the start given instead of 20 meters was something like 15 meters or even 19.99 meters, then B would have won the race. Since the start was 20 meters, it was a dead heat. If the start given was more than 20 meters, then A would have won the race. How do I come at that magic figure of 20 meters? From the previous case, where I found out that B is beating A by 20 meters. So once again, if I look at the analogous side in case of time, if the start given is more than 1 second, then A wins the race. If the start given is less than 1 second, then B wins the race. If the start given is exactly 1 second, then the race finishes in a dead heat. By dead heat, I mean both of them finish at the same time. Please stay with us to continue the discussion on time, speed and distance. Thank you.